All right, let's get ready for some hard-hitting stuff. No, not really. This is just an extension of redox reactions and being able to go to the next level and being able to balance very complex molecular equations. So you've had some of these things that go up. This one's probably pretty easy. This one may be a little bit harder. Some of you might be split on this one being easy or hard, because if you don't know the polyatomics, that might scare you off. Then we go, oof, and then we're like, how would you even balance this? Well, the reaction I'm going to show you the way to do it is going to be the simplest. We'll work our way there. So, looking at the acidic method, some points to remember: you never have electrons in the final answer. Those will always be canceled. Duplicate items are always removed, usually electrons, water, hydrogen ions. Sometimes some other stuff, but those are general. So steps: you break it into the two half reactions. You balance each charge. So the elements, you usually start off with water, then hydrogen, then finally electrons. Equalize the electrons by multiplying the half reactions for each of them to balance and cancel out, and then shove them back together. Usually you'll have an H plus in the end because it shows it's acidic. Not always, but that's usually the case. So let's take a look at our first example here. So we have a net ionic equation. The sulfur is going to be changing, the nitrogen is going to be changing. Generally not oxygen, but it could be. And so we want to start balancing these things on the right side. So I can see I'm down some oxygen. So in order to bring that back, I'll need to have 4 waters added. Oh, that's an H, sorry. Got ahead of myself. Because water's present in an acidic medium. So I've got 4 oxygen on the left, 4 on the right, 1 sulfur, that's good. Then I can look at my hydrogens. I have 8 on the left, 1 on the right, so I need to add 7 hydrogens. And remember, these are H pluses. Finally, I need to look at my charge. 2 minus in total on the left, 6 plus over on the right. So in order to take 6 plus to 2 minus, this will need to be 8 electrons added. Next, I look down here. 1 nitrogen, 3 oxygen. So to get 3 oxygen on the other side, 2 H2O, so I got total 3 oxygen. I've got 4 hydrogen on the right, which means I need 4 on the left. Don't forget it being a plus. And then I look at charge. 0 over here, 3 plus over here. So that means I'll need to add 3 minus, 3 electrons. Next, I'll need to see how I can cancel out my electrons. Quite often it's common multiples. So 3 and 8, multiply the top times 3. So I'll have 24 electrons. So this will become 12. The thing that had a coefficient of 1 will become 3. This will become 21. And of course, my 24 electrons that I'm trying to cancel out. On the bottom, everything needs to be multiplied times 8. So that's why I got 24 electrons over here. So times 8, that's 32. 8, where there was once 1. And times 8 gives me 16. So from here, then I want to cancel things that are in common. So I can see I've got 12 waters on the left, 16 on the right. So if I get rid of 12 on each, that gives me a total of 4 waters. You can rewrite this, but again, if you're trying to save a little bit of time, this can help as well. I've got 21 hydrogens over here, 32 over here. So 21 gotten rid of on both sides. That gives me 11. These you're generally not going to cancel anything out. And again, my electrons are canceled. So to make this a little bit clearer, we've got our 3 of the S minuses plus our 11 H pluses. Remember, all on the left, plus 8 NO3 minus I'm just going to go down because I got a little bit more space. And then I have my 3HSO4 minus plus my 8NO, doesn't matter about order, just make sure you get everything, plus my 4H2O. So double check to make sure you don't have anything doubled on either side, stuff you could eliminate. And if you do everything correctly, you really should have all of the charges and elements all balanced. It's kind of in the process of you doing this procedure that you're going to come to this ending solution. All right, let's look at another example here. We have our net ionic. We're keeping our bromines together, our nitrogens together. Now I'm going to let you in on a little secret. I've messed up on this 3 times during this. You need to check your non-oxygens and hydrogens. I have 1 bromine here. I have 2 on the right side. So I need to multiply this side times 2 first. Always make sure your elements that are not oxygen and hydrogen are the correct before you get started. On the left, I've got 6 oxygen, so I need to add 6 oxygen on the right, and that includes our waters, right? I now have 12 hydrogen on the right, so I need 12 on the left. Don't forget it's H+, because then I need to balance my charge. I have 11, no, I'm sorry, so see, 2 times that is -2. So I have 10 on the left, so I need to add 10 electrons on the left to cancel those out. All right, that's looking better. Next, I come down here. Check your nitrogens, 2 and 2, good. Hydrogens, so now I need to incorporate 4H+ over here. No need to do anything with oxygen. And then I look at my charges. I have 4 over here, so I need 4 electrons present over here. Good. So, common multiple, you might be tempted to say 40. You could go that direction, but the lowest common multiple would be 20, right? So if that's going to be true, everything on top gets doubled. So this will be 20. This will be 24. Doubled gets 4. Doubled gets 2. Doubled gets 12. Bottom, everything gets multiplied times 5. So this will be your 20. That's why it gets eliminated. This too will be 20. Every times 5 and times 5. Right, now I need to eliminate my stuff. You got your electrons you can eliminate. Hydrogen, I've got 24 on the left, 20 on the right, so these will go away. This will leave me with 4. And that looks like it. I don't have waters to cancel out. All right, so just totaling it up so I got it clear. So 4H plus the 4Br03 minus plus the 5 and 2H4. And then on the product side, my 2Br2 plus my 12H2O. And don't forget the 5 and 2. All right. So from here, this is what you do for acidic. Basic is another one little step extra, and then we get to molecular, which is taking it to the last step. Let me know what kind of questions you have, and I'll see you soon when we do the basic side.